Hello there. This is a video presentation for subject SSCE 1693 Engineering Mathematics 1 Semester 1 2023/2024. We are in Group 10 from Section 41. I hope you can give full of attention for what we gonna teach. As you can see on the screen, we will present about type of a solution for a system of linear equation, especially for a unique solution. Before we present our topic, may I introduce you for our group member. My name is Muhammad Hisyamuddin bin Zulkifli, and for your information, Muhammad Alif Nabil bin Junaidi is our leader for this group. With the support of two other members, which is Muhammad Syahdanial bin Muhammad Saidi and Muhammad Haiqal bin Roslan. This is an introduction for our topic. Solving system of linear equation use elementary row operation (ERO) and matrix method. ERO will divide to two other methods, which is a Gauss elimination and Gauss-Jordan elimination. For a matrix method, it will also divide to two other methods, which is inverse matrix and Cramer's rule. The system of a linear equation with m linear equation and n number of variables can be written as a11 x1 plus a12 x2 plus until plus a1n xn equal to b1 for the first equation, a21 x1 plus a22 x2 plus until plus a2n xn equal to b2 for a second equation, and it also can be written until am1 x1 plus am2 x2 plus until plus amn xn equal to bm, as you can see in this slide. A solution to a linear system are real value of x1, x2, x3 until xn which satisfy every equation in a linear system. Before we talk about a unique solution, let us consider the following theorems, which is homogeneous and non-homogeneous theorem. Given the homogeneous system of a linear equation is ax equal to 0, that means b equal to 0. And the non-homogeneous system of a linear equation is ax equal to b, which is a common equation for matrices. What is a unique solution? A unique solution means only one solution. If a linear equation has a unique solution, means only one solution set exists for the equation. The system has a unique solution if P in bracket A equal to P in bracket A B equal to the number of variables. This is the fundamental formula to identify the unique solution. For the next slide, Shah will show you some example of a unique solution.
Okay, now for example question 1, we're gonna solve this equation using Gauss-Jordan elimination method. Firstly, we have to change the equation, the simultaneous equation, into the matrix form, which have A, X, and B matrix. A being the coefficient of the variables from each equation, 1, 3, 0, like this, 1, 3, and 0 for the Z. X being the variables for the equation, which x, y, and z, and b being the right hand side of the equation, which is 19, 10, and -5. Then we have to form this one singular matrix which have A and B, A on the left side and B on the right side. To use this method, we have to bring side A into identity matrix like this one, or RREM form, which is 1 0 0 0 1 0 0 0 1. After you get the identity matrix from this matrix, the right hand side of the matrix will become the answer for our simultaneous equation. Okay, now to bring the matrix A into identity matrix, we can use adding, times, and divide our row to change them into 1 0 0, 0 1 0, and 0 0 1. While at that, you also have to change the right side of the matrix so that the answer at the last matrix become your x, y, and z. Now, if we get the answer for all our variables, this means that our solution is unique. We can know that by look at the rank of our matrix. For example, one row is one rank, so every row that has variables mean 1. So for our matrix, we have rank 3, because we have number at every row. Now to check our solution, let's see that our rank for the matrix is the same or not. For rank A, which is our initial matrix, is 3. Rank for AB, which is 3, and our variables is 3, means that our solution is unique, and this will give us the answer for our simultaneous equation.
Okay, now my part. I am Nabil from the simultaneous course. So I will explain how to answer this simple question and identify whether it is a unique solution or not. From the question, given the first equation, which is x plus y plus 2z equal to 7, and the second one is x minus y minus 3z and equal to negative 6, and the last one is 2x plus 3y plus z equal to 4. So how to solve this question and identify it is unique solution or not? So to answer this question, I will using inverse metric method. From the linear equation just now, we need to convert first to metric form, just like in the slide, and label as ax and b. Next, to solve using inverse metric method, we need to find inverse metric of a first. And to find inverse metric, I will use arrow, which is elementary row operation. As we know, arrow need to make the matrices has a zero triangle at the bottom and top. So, in order to change value 1 at the row number 2 to be 0, we need to make the formula, and the formula is negative R1 plus R2. Then, the row number 2 also need to change to make the median number to be positive 1. And to make that, I use the formula negative 1 over 2 R2. Then, after that, we need to change row number 3 to make the first and second column become 0. So, I use formula negative 2R1 plus R3 and negative R2 plus R3. After that, to find inverse, we need to make the matrix to get number 1 crosswise. So, negative 11 over 2 need to change using the formula negative 2 over 11 R3 in order to make it become value 1. After finish 0 triangle at the bottom, we need to make 0 triangle at the top. To make that, we need to change row number 1, second column and third column. So, by using the formula negative R2 plus R1 to change row number 1, we can get 0 at the middle of the row 1. Lastly, using formula 1 over 2 R3 plus R1 and negative 5 over 2 R3 plus R2 to get zero triangle at the top. So, if we can get inverse matrix, then this question has a unique solution. But we also need to solve first to know that the number of unknown to satisfy the rules of the system to know whether it is a unique solution or not. So before, at the beginning, the formula is AX equals to B, right? We need to derive the formula to know the unknowns by multiply both sides with inverse A and become X equal to inverse of A multiply matrix B. So X equals to 8, Y equals to negative 1 and Z equal to 3. So we obtain that rank of matrices A equal to rank of matrices B and also equal to the number of unknown, which is 3. Thus give a unique solution. So that's all from me. Thank you.
Example question 3. As you can see, I already found the question, so we can solve it using Cramer's rules method. In this matrix form, A is filled with the coefficient of the linear equation and X is filled with the variable of the equation and B is filled with the answer of the equation. The first step in Cramer's rules method is to find the determinant of A. So I choose the the number on the first row, which is 1, 2 and negative 3, and when I choose 1, I will eliminate the number on its position, which is first row and the first column, and left with this number, which is B2, C2, B3 and C3, and we put it in this box. Same goes with this equation. I choose negative 2, which is in the first row and second column, and left with 1, 1, 2 and 3, and we put it in this box. Same goes with C1 number. And then after we already arrange it in this position, we cross multiply the number on this box, which is negative 1 multiplied by 1 and 1 multiplied by minus 1 multiplied by 2, and then we gonna get the answer of determinant of A, which is negative 2. And when we get the determinant of an A is not equal to 0, meaning the matrix has only one solution. It also known as a unique solution. And next, we need to find the determinant of AX. The meaning of determinant of AX is we replace the first column of the coefficient and replace it with the answer of the linear equation, which is negative 4, 3 and 10. And then we do the same method as we do to find the determinant of AX, which is choose the first row and eliminate the number on its position and fill it the box with the remaining number, and then we're gonna get determinant of AX equal to negative 22. For AY, we replace the answer of the linear equation into second column and find the determinant of the AY position. AY meaning, so next step is to find the AY determinant. AY determinants means we replace the second column of the A matrix with the answer of the equation, which like this, as you can see. And then we're gonna repeat the next step, which is to find the formula using the formula of determinant. We find the determinant of AY, and we get the answer of determinant AY is negative 44. After that, we need to find the exact determinant. That exact is the matrix that we replace the third column of the A matrix with the answer of the equation, and then we find the determinant using the determinant formula as we do like usual, and get the answer negative 66. And last but not least, the final step of the Cramer's rules is to find the x, y, z value. For the x value, we need to divide the determinant x we get yearly with determinant of A, which is negative 22. Divide by negative 22, we get 1. And y value, we use the AY determinant value, divide by A determinant value, which is negative 44, divide by negative 22, we get 2. And exact determinant Z, divide by A, left with the answer of 3.
Thank you for watching. That's all from us. Bye.